Hi, I'm Deng from Cornell. Today, I'm co-presenting with Wuxinlin from Stevens about our work, SPADE, which is a spectral method for black box adversarial robustness evaluation. This is a joint work with Zhiqiang, Yao Hui, Professor Zhang, and Professor Feng. Our motivation is that a non-robust ML model will make a wrong prediction even if we add a small adversarial perturbation to the original image, which will cause real issues for security-critical applications such as self-driving car. Therefore, it is very important to have a metric to identify robust ML models. There are two kinds of existing robustness metrics. The first one is the accuracy score on adversarial images. However, the accuracy score depends on a specific adversarial perturbation, which may cause a biased evaluation. The second one is called clever score, which computes the gradient of the model prediction with respect to the original images. However, computing the gradient requires access to model parameters, which may not be available in realistic applications. In this work, we propose the SPADE score to evaluate robustness, with the assumption that the input and output data lie in the low-dimensional manifolds. Since our metric only requires the original input and output data, it is agnostic to adversarial perturbation, and is also a black box evaluation method, which means that there's no requirement to access model parameters. Once we compute the SPADE score, we can use it to measure model robustness. Moreover, we further extend the SPADE score to measure robustness of input samples. To measure model robustness, our basic idea is that a non-robust model maps nearby input data to distant outputs. To quantify this idea, we define distance mapping distortion, gamma, as the distance between outputs over the distance between the corresponding input samples. Intuitively, a non-robust model should have a large gamma. However, finding the largest gamma among samples in the manifold is expensive. Instead, we approximate the manifold by k-nearest neighbor graphs whose Laplacian matrices Lx and Ly capture the effective resistance distance between samples in the graph. Consequently, we prove that the largest eigenvalue of Ly pseudo-inverse times Lx, which is defined as the SPADE score, is the upper bound of the largest gamma. Therefore, we use the SPADE score to approximate the distance mapping distortion. A larger SPADE score indicates a model is less robust. We evaluate the robustness of several CM models that are trained with different adversarial perturbation epsilon. A larger epsilon indicates a more robust model. As shown in the tables, the SPADE score decreases when increasing the epsilon value, which means that the SPADE score consistently reveals the non-robustness of ML models. Next, Wuxinlin will present how to extend the SPADE score to measure robustness of input samples.
Motivated by the largest eigenvalue, can capture non-robustness information, we further utilize the top k largest eigenpair of pseudo-inverse Ly, Lx to do the same thing. Especially, we define a spectral embedding matrix V as following, where the lambda k and the vk are the first k largest eigenpair. We use V to encode each node in the KNN graph into a vector to capture non-robustness information, which is then used to capture the SPADE score per node. A large SPADE score indicates a sample is less robust. After computing node SPADE scores, we can identify a non-robust sample and use them to enhance model robustness and robustness evaluation. To enhance model robustness, we assign larger adversarial perturbation epsilon to more non-robust sample during adversarial training. The table shows our method achieves higher accuracy on CIFAR-10. To improve robustness evaluation of the existing metric, we compute clear score with non-robust sample instead of random sample used in the original approach. Guiding by SPADE leads to a smaller clever score, which shows that SPADE improved performance by exploiting non-robust sample. Thank you for watching. Our code is available in the Phone Research Group.